Good evening, everybody. I'm going to get started, so we're not here late. Tonight, we have our most famous speaker, Dr. Dewey Caron. Support Pub. There's lots of things going on. Swarm List has been super hot this year. You don't know how to join, it's free bees. That's all I can say. There's a Bee Buddy program. You can get a mentor or be a mentor. My mentee just put up a Nest camera so I can see his job. He's very excited. Bee days at the apiary, 2 days a month. We have a library and equipment rental, extractors, any equipment you could need. Very important is the OSBA, Oregon State Beekeeper Annual Summer Picnic in Tillamook. Their apiary is amazing, and it's definitely worth driving out to the coast. Saturday, July 25th, 10 to 2:30. Free food, door prizes, and more. RSVP on the OSBA's website. So upcoming events this weekend, we have EpiPen training. If you saw the presentation on allergies, you'll want to be there. I think it frightened us all with the photos. Learning Apiary is July 19th. Gather and Blather is July 25th, last Saturday. Portland Pickles game, OMSI night, games at 7 at July 30th.
We'll have a booth. It's
Excellent.
a Thursday.
Yeah,
It'll be
always fun. Are we throwing out
fun.
a pitch?
I am throwing out a pitch. There may be other pitchers, I don't know. I'll be one of them.
August 5th is the second most famous speaker, Anthony Methanopoulos, nectar and pollen plants of the Pacific Northwest. And then August 29th is Gather and Blather at Paladins League. Learning Apiary is first and third Sundays, 10 to 2. Jana and Stephen are hard at work there. Okay. Dewey, I'm going to introduce you.
Can you go back to the calendar?
Oh, the
Yeah.
calendar. Thank you. Was I not advancing the slides?
No, they weren't advancing. It's okay though.
Okay. Yeah, there's the schedule. Everything should be up to date on the website too. So Dewey Caron, I don't know what you can say here. He's Emeritus Professor of Entomology and Wildlife Ecology at the University of Delaware, and Affiliate Professor of Horticulture at OSU, 40 years teaching bee extension and bee research at Cornell in the 60s and 70s, University of Maryland, College Park in the 80s, 70s, and 80s, and University of Delaware, 81 to 2009, before retiring. I don't think that's really what you did. He's in Oregon. He remains active in bee education, writing bee short courses. Our textbook is written by Dewey, the complete bee handbook and honeybee biology and beekeeping. If you don't have it, we have some for sale. And he's a major contributor to Honeybee Health Coalition. So without further ado.
And that's him at the Pickles game
That's
that
the
he came
Pickles.
to
That's
last
the Pickles.
year. Just saying.
That's a great photo.
That was a fun night, yes, we had a good time. All
Okay,
righty,
Dewey, we have 30 people online, so
okay, all righty,
Um,
thank you.
what-
Pleasure to be able to join this evening. Going to talk a little bit, just very quickly in terms of the survey, because I've already had a chance to give you the first initial overview. The survey results are online for the same place you took the survey, PNW Honeybee Survey. So you can see that information there. That photo, by the way, I went back to, I started some groups 50 years ago. So, yeah, look the same. Thank you. Oh, you're so kind. So that's one from going back when I first started in a position. Actually 60 years ago, but 50 years ago. Our other anniversary, the 200th anniversary, I started 4 different clubs, and we went back this year and celebrated the 50 years of the club forming.
I have no idea. Oh, it's up there.
Nice
for some
sneaking
reason.
suit, huh? You see the uniform of the day. huh?
Uh-oh, I don't know what just happened.
See the
Where did it
uniform of the day?
go? Don't know.
Are those online? You're checking out online.
We can't find the mouse suddenly.
Can't find them out, so.
Okay,
Oh, found it.
Go ahead.
Okay.
Okay, can we close that?
Okay, what do these two have in common? Next. As you know, they're both yellow jackets. That's that aerial horn. It's actually a yellow jacket. And they're coming. That's gonna be our issue pretty soon. Next. A couple new books, Bitter Honey is a expose of the industry and what ails us in the industry. By Jenny Durant, very well researched, talks to the major people. This is just out. And the other is we're doing a lot more with veterinarians and training vets. And we do have now a second edition of our honeybees for veterinary practitioners, and that'll be out a little bit later this fall. I have a chapter there. So Jenny and her stocks in bitter honey. Bee declines may seem like an environmental tragedy at the margins, but the losses destabilize our food system. The problem is a series of isolated issues. It's a nexus of stressors built by the very ag system that depends on them being honeybees. So it's really a very in-depth look in terms of how agriculture, particularly things such as almonds, have really changed our industry. I think you might enjoy the stressor. Okay. What's wrong with this picture? Beautiful honey yield going there. You can see on the right. Next. This is the first of the slides for the losses. For pub losses, they were 21% last year, which is marvelous because it's below the state level losses of 24%. Because this is converted over to Apple, couple of these are not going to show. Next one. So this is a look in terms of, I asked you by losses by hive type. So laying 8s, laying 10s. This is, you can see statewide is the darker and the pub is lighter. Most of the groups, laying 8s do better than laying 10s, as you can see. And usually nukes and top bars usually have higher levels of losses. As I indicated, most of these I've talked about these in the results. Next. That's another one.
did it get,
Yeah,
Stuck
this
here?
got duplicated. What I wanted to show, this is our losses. I have good records back to 2014 for the group. Notice the trend line, that's that orange line. So we're doing something much better. So the other numbers up here, so this red line that goes through is backyard, you and I, under 50 colonies, and the green line is state commercial, that is 50 and more, sideline or commercial. And you notice now that they are about the same. So that at one time we were having at least double losses of the commercials. Unfortunately, they've caught up to us, or more importantly, we've been able, and for us with a smaller number of colonies, to reduce our losses. And I think it's to meetings like this and clubs like this that are so active. Next one. Well, so that came up separately, but you can see this last year, 21% level of loss. And as I say, it's under the state. So 25 individuals. So the pub returns were 57 individuals. So 25 individuals had no loss. That's fantastic. No loss at all. Unfortunately, 8 had a total loss, but here is the level of losses. So 13 individuals lost 1 colony, all the way over to the heaviest loss for the club. 1 individual lost 6 colonies. Next, we are a group pretty much of individuals that have small numbers of colonies and not a great number of levels of experience, but both for pub and for statewide, as the number of colonies you own or managing increase, I've only shown here 1 to 3 or 10 plus colonies, the level of loss goes down. For the club here, 1 to 3 individuals, 26%, 33 of the 57 individuals. 6 individuals had 10 or plus colonies for the club, 25% level of loss. You can see statewide, that's really fairly significant. For years of experience, individuals, 13 had 1 to 3 years experience at an 18% level of loss. 15 individuals had 10 or plus, but had a heavier loss. Statewide, it is pretty much even. For many of the clubs, it makes a difference, but you can see statewide. Years of experience didn't make a difference in terms of level of loss. Now, not numbers of loss, but percentage level of loss. And I ask you why. So here are some of the reasons. Queen issues and week in the fall were the two most popular. None of this is you know, there's no police to go out and check. So this is your own reason why you thought you have a level of loss. And then the other line is acceptable. So 14 individuals of the 57 said no level of loss was an acceptable number. But one individual said 100% level of loss was acceptable. So you can see the range. And the median was 20, same as the state. Okay, enough of the numbers. Still with me? All right, let's go on. I'm going to talk about what we've just passed, our summer solstice, and then how that's going to affect now our management. So we have these 4 quadrants of the year, and our management is pretty much keyed in that. We've passed the longest day of the year, 9+ hours of sunlight, well, past 9 o'clock, a level of sunlight. And with that, then some changes occur. So in the next one, and that's that quadrant from the first day of spring until the first day of summer is when bees are very easy to do, very forgiving. We can make lots of mistakes. We can make the same mistakes over and over, and yet the bees will recover and bees will do okay. We can add bees to a colony. We can easily, rather easily have them replace their queen. A lot of different things are much easier. Now after the summer solstice, things get a little bit more difficult to do, and timing becomes a lot more critical. So if you've had an easy time with it starting, if you're starting this year, things will get a little bit more difficult because timing is so critical in how we do our management. Next. I talk about the both the stressors to us and to as beekeepers and to the bees. And part of that, of course, is our long hot days and our large colonies. Next. Going to talk about a couple things. Summer solstice, how it does affect our management. Stress in bees, examples of some summer stressors, and then I'm going to go ahead and finish up with mites and how we might be thinking of integrating some of the tools. Okay, go on. Our level of stress for our bees has been pretty low, and mostly for us as beekeepers. As I say, they're so easy to work with when they're so busy. We finally get a balance of the population after the spring start, and they're just tooling along. Things now start to not tool along quite as well. So perhaps our level of stress going from the green initially here in July, maybe in orange, but by the time it gets around to September, October, there are a bunch of stressors to our bees, including us as the beekeeper. Next. There are plenty of stressors that we can isolate and talk about. You've seen different slides, different people have different ones. So things such as the pests and pathogens, changes in climate, habitat, certainly management ourselves, and agrochemicals. So there's plenty of culprits to go about to talk about. Jenny Durant in the Bitter Honey has the first chapter, 7 different chapters isolating one of these things that has really changed bees and beekeepers. And then has 3 chapters, only half the amount of text, to some of the solutions or what of how we might be able to improve our beekeeping and improve our stress to our bees. Okay. So stress is any physiochemical environmental disruption that pushes baseline biological functions outside of normal healthy limits, healthy range. And bees, we need to talk about in terms of stressor individuals, because the colony is made up of individuals. And so things that may be aspects of stressors, for example, are the precocious foragers, bees that become foragers due to demands of the colony, due to changes that are physiological within their own bodies. Another good one is in terms of gut immunity, and that has a lot to do in terms of how they are being stressed. Nosema, for example, robbing them of food in their gut, which they need for their own nutrition. But because we're talking about bee colonies as this social organism, what some would call that supraorganism, we also need to talk about colony level stressors, or the resilience to those levels. So for example, we're getting on a period now where no matter where you have your bees, the resources are not the same. You might be in more of a drought area than in other areas, but the resources are not the same. So there is a nutritional stress that is going to if it's not now in your colonies, very soon is going to be a factor that's going to affect colony level resilience as well. And then as one of the responses that they might do is they simply leave home. In some parts of the world, such as where I go with Afghanized bees, when they leave home, they find another place and they survive on. In our bees with absconding, the survival rate is virtually nothing, because they just are not going to have enough of a season to establish a new nest. Even if they go into used equipment, for example, establish a new nest and be able to survive our winter. Okay, so two levels in terms of individual and then colony level. Right?
Can you speak about precocious foragers? Never heard that term.
Cautious foragers, so bees in there, we talk about the caste system in females of a queen and a worker having that division of labor. But within the worker bees, there's also a caste in terms of what their age is, both in the queen, early queen and older queen, for example, but also in the workers. And so the last part of their life is foraging. Well, in a normal sequence, in terms of having a balance of ages of bees in a colony, they're not going to start that aspect of foraging until they're closely getting to about 3 weeks of age. Precocious foragers are those that are pressed into service for foraging at a younger age. So they're younger, and that means things that they need to do to be able to maneuver out there in the big world as foragers may not be physiologically or in terms of the neuron connections in their brain might not be in place. So they're early, they're foraging at an early age, where that's a stressor, because they're not primarily physiological, but also behaviorally not prepared to do it. Okay, good. Bill?
Is this due to the fact you have a small colony and they just have to do this? Is that why they become?
It can be, yes. So it can be due to a small colony, they have to do it. There may be other factors as well. Certainly this balance of having enough bees to do all the various jobs. Now at this time of year for colonies that don't have that balance really becomes critical. In the earlier part, from March to June, there's enough resilience in the population that they can recover and still be productive. Now, when these things happen, after the summer solstice, recovery, these stressors may make recovery very much at risk. Yeah. But certainly, small colonies is one of the factors. Of course, the other is in terms of, so this is all mediated by hormones that are in the bee's body. And these are balanced by having balancing of adult ages and brood. So if you have a mismatch of either of those two, then they may become precocious foragers, because they don't have the right hormone balance in individual bodies in response to what's happening in their home, their colony.
Is there information on this in your honeybee biology?
Yeah.
That's
Yeah. Okay, so two levels. And ourselves next is stressors certainly is one of the factors. Next, we could get away with it earlier. Now it's going to be much more difficult, no matter what we're doing, whether we're setting up a new colony, we're moving a colony, whatever might be the case. We can still set up colonies, but we just, now it kind of becomes very critical in our timing. So here are a few of the things that I'll talk about as we turn past this summer solstice. These represent changes. Any of these changes then can be the stressors that then lead to imbalances. Okay, next. Certainly, our industry has changed, so that now pollination services are the income generator for the large beekeepers. But for us with smaller than a number of colonies, still honey is often the reason for our keeping bees. But that certainly has changed, and this is one of the factors that that author in Bitter Honey brings out as one, not only changes in other farmers, but changes in the farmers of those that need bees, the pollination service. Next. Some of these are, of course, we talk about this being a smorgasbord of only a single source. And as such, then there's no one perfect food, whether it be almonds or whether it be sunflower. And pollination brings on that stressor in all of the colonies that have to serve. It is not a balanced diet, nowhere, shape, form, and yet bees need that diversity. Okay, so that's certainly one of the stressors. There are still stressors in terms of pollination. At this time of the year, most of our pollinators are trying to find a safe haven, trying to find a time out for their bees, trying to find something that is not going to be this single type, this single source. But even some of the single sources, such as sunflower, et cetera, will be a factor. We have the favorable condition in the backyards where we're going to have a greater diversity. Although, again, that diversity that we have, the bees have been enjoying, and we've been enjoying our landscape, does become in short supply now as we enter in this next quadrant after the summer solstice. Even if our bees are real bees or artificial bees. Next. So changes in keeping bees, and initially bees were in trees, and there still are beekeepers in Europe that keep bees in trees. So these are log hives of individuals, and they do a harvest that we call destruct, but they don't destroy the honeybees. They drive the honeybees away and destruct all the rest of the work, the comb, and then have the harvest of products such as honey, but also the brood and bee bread, and of course the wax itself. So changes in how we run our bees, certainly. Next. And whether it is a single colony or multiple colonies, we really have no handle in terms of stocking. How many colonies should be in our backyard, or how many should be handled by a commercial beekeeper in one particular location. In other words, a carrying capacity of the land. And of course, carrying capacity varies. So in the spring, it almost can't have too many colonies. If you're on a nectar flow, again, can't almost have too many colonies, but we're going off of both of those conditions, out of the spring and off of nectar flow. And now carrying capacity is very much a factor in terms of stress and added stress to our colonies. Next. Queenlessness, defensive robbing, because we haven't been looking at colonies as we've added supers. Generally, we're not looking at the colonies as extensively. So now these behaviors become a lot more prominent in our colonies. So what was once a gentle colony now becomes perhaps a defensive colony. Certainly, we are the people that we are the beekeepers. As beekeepers, we are initiating this robbing of colonies. And then because we haven't been looking as diligently in brood nests, we end up with as many as 20% queenless colonies. I don't know if you have started taking supers, have started harvesting, but it's not at all unusual to find that what was a very good, very robust colony now, as we get the supers off, doesn't seem to have a queen. It has to do, of course, with queen replacement. They do it better in the spring, but now that we're after the summer solstice, now when they will be replacing queens by, for example, supersedure, things go wrong in that process a lot more than will go wrong, for example, in the swarming process. And because it's spring, the bees can recover, and now they're not going to be as easy to recover. Next one, I think is on queenlessness, defensiveness. Robbing, again, we are the ones that we are the responsible for that behavior. Queenless colonies, an indication queenless colonies, most of the colonies are missing at least two ingredients to make up the nucleus. They're queenless for weeks, which means they are likely also broodless. Drone brood doesn't count. At this point, it's really hard to get a queen introduced. So we could do that much more easily in the spring, whatever way we wanted to try to introduce or let the bees rear their own queens. Those things then are not happening, are not as readily happening as well. And so we'll find colonies that have these popcorn drone brood, what we call popcorn drone brood, just a few drone brood cells left, maybe a few scattered worker cells left. And now it's going to be very difficult to try to go ahead and do management. If you do not have a resource nuke at this point, you're going to have, it's going to be a challenge to try to get a queenless colony that you discover as the supers come off, get it back to a queen right state. And get it back to a queen right state that's going to have a chance to get through winter. Again, in the spring, we can do all those things, do it rather easily, but not as much over as we get it after the summer solstice. Next. We may see multiple eggs in cells, as we see here. Certainly an indication that laying workers have become established. They're always present in bee colonies, and then take the queen away, then we're going to have a lot more of that particular possibility. Diane?
You said if you don't have a resource nuke, you're gonna have trouble requeening.
Right.
How would you use the resource nuke to requeen in that situation?
So a resource nuke is just a smaller colony. It has a queen, it has some brood, and it has some honey. So that's what I'm talking about, a resource nuke. So how would you use that to requeen a queenless colony? You make a decision, you know, what kind of population do I have in this unit that I'm now judging to be queenless? If it's a decent population, then you're going to try to combine the resource nuke with that population.
So just a straight combine.
A straight combine, but in the spring, we could just simply put one together with the other. Now we've got to try to protect the queen so that the portion that has the brood in it, you're going to try to protect with like newspaper so they have a chance so that they're not going to immediately try to kill the queen.
Okay.
And where that was much more successful in the spring, now it's not going to be as successful. With the chance of success. Okay, next. Our sources become less reliable, whether we're actually in a drought period or not. Certainly the amount of resources has slowed down. It's been a pretty good year for a number of beekeepers this year, but it's going to be reduced. Now they're going to be involved in collecting water, just simply as temperature control, certainly. Now we might be needing to think about the resources. If you started any colony this spring, now while we can still get away with doing some things, it'd be the time to check and see if you need to be the individual that's going to give them that resource. You're going to feed them sugar water, or you're going to feed them the pollen patty. The later you wait to do that, then the chance that you will have success in getting them through the winter is going to be reduced. But we can still do that now that we've just passed the summer solstice, the longer we wait. And of course, some years we're going to wait in terms of doing our harvest. And so that drags us off into August, or we're on vacation later August. And then trying to correct some of the issues, such as queenlessness, such as a very defensive colony, is going to be a little bit more it's going to be more difficult to try to do versus what we could have done in the spring. And now we've got to do other activities with our bees, such as feeding them other materials, right? And again, a recommendation: feed the new colonies, continue feeding new colonies. And if you have nukes, resource nukes, consider feeding them as well. Next, sugar water, and then the protein patties. There's the number of new developments in terms of protein patties. The Man Lake has bought out a company, Apex, that have a product that's called Canadian Rocket Fuel. And it's protein and vitamins and some other things in a sugar syrup. And it makes a difference in terms of being able to make a difference. In feeding protein, any pollen is better than no pollen in that protein patty that you might feed. But by large, bees know the difference between a spring pollen and a fall pollen. So that if you have the ability to trap pollen, you can now trap some pollen to be feeding to your colonies this fall versus relying on the products that have pollen that are in them. Mainly because that product is pollen that's been imported into the United States, and it is not seasonally specific pollen that the bees will be able to recognize and will be more useful. But all these products cost more money, but they are, we're making, I think, some rather significant advances in terms of what is needed nutritionally for bees. And this is by and large through the project that we started at Oregon State University when we brought Priya on board as a postdoc, and then her work when she went to Mississippi, and she's now in neighboring Washington State, of recognizing that the diets that are available are not nutritionally complete diets or nutritionally adequate diets. And so if we're feeding this material with an expectation that it is a good diet or a great diet, and it isn't, then we're adding additional stressor to our bee colonies, additional stress. Next. And of course, why we would want to feed the protein in the fall is we need to create the bees that don't go through brood rearing. Okay, the fat fall bees are bees that have in their bodies more fat body, and they have fat body in their bodies because they have not activated to a great degree the brood fruit glands in their head. In other words, have not become nurse age bees to feed the young bees. That's what the fat fall bees are. They're going to suspend the aging process and live for a period of 2, 3, 4 months versus 2, 3, 4 weeks as they would have, as they are now doing at this time of year. Next. Here's this new product that they bought, this Apis biologic. Unfortunately, what's happening in addition to large beekeepers becoming larger, our supply industry has become more restricted because, again, the suppliers have become larger rather than smaller. Next, and there's another one another one, Apex. You know, everything wants to start with AP, of course, with chemicals, and now our nutrient materials as well. This is again a product that does apparently also, from what they're putting in it, is going to have the sterols. The sterols are very important in terms of having a more complete nutrition for bees, particularly when bees need it for pollen, when they feed as very young bees for those brood fruit glands, and now to be able to have enough nurse age bees in our colony so that bees being born don't have to become nurse age bees. All right, they then can pass through a longer winter. There's going to be Apex pollen. It's not yet on the market, but it will be on this one. So we're talking in terms of now the difference in our nutrient materials of knowing the macronutrients, the protein and the carbohydrates, but what seems to be really critical if we're going to have reduced stress and come up with those diets that the bees need are all those other ingredients as well. Why we might prefer honey over sugar syrup, because honey has all those other things that are in it in addition, which sugar does not. And so let's go on to the stressor that we need to manage for it in the fall. Those are going to be mites, of course. Mites, we have 2 populations to manage. Now we need to fine tune our controls. We can do a bunch of different controls in the spring and affect numbers of mice. But now in the fall, after the summer solstice, now it's much more critical, and timing now becomes much more critical as well. Next, I indicate, we got our 9th edition out, June 22nd, we had our release. This has all of the new information and a bit of a new emphasis in terms of how we might look at tools, our own tools, our external tools in terms of mite control. So if you've got an older edition, I recommend that you go on and read and download the newest edition, the 9th edition. Okay, next. I'm indicate two populations. As beekeepers, we're always managing our bees, or that's what we started with in bees. Our blue line here, all right, we're now past, for most cases, our population peak. And although it may not immediately be evident, the colony is decreasing. Of course, that other population is those of the varroa mite. Because their numbers in the spring are lower, they too grow at a very substantial rate. But right at this particular point, I think the next slide is it. The point I want to make here was that most of our tools were developed for this time of year. Okay, most of our tools were developed for this time of year. Next, please. But it is often too late. All right. Next. Although our colony may have increased fivefold, you'll notice that we have something in the vicinity of perhaps rather significant number of mites in developing colonies have not yet reached their peak numbers, even though their numbers in spring were very, very low. So we're still at this particular point, but look at all the years still left for mites. So that's our stressor. That's what we need to work with in terms of helping our bees respond. Next. So our idea in terms of mite control is to, we can't get rid of all of the mites. That's not possible. So we really need to manage them or manage the pests. So we talk about integrated pest and pollinator management, lost up here at the top. It really has four tenets. We need to know the enemy. We need to monitor their growth. We need to determine a threshold of risk. So if we do something or didn't do something, what is the risk that that pest is going to cause real damage to us or to our bees? And finally, then consider levels in terms of control. And we do have a number of control options. Next. The concept that I want to try to emphasize is what we prefer, what we discuss in pest management is economic injury level. So we have a pest, okay, their numbers are growing. You saw on that last other slide, their numbers are growing. At some point, they may pass a level that's going to cause some damage to the bees. Might be reduced numbers, reduce the age of the bee. It might be fewer bees that are able to go through the winter because they've been damaged as they were growing up as pupae, for example. It might be, of course, with mite distribution, all right? So at some level, we're going to pass that particular number. We don't know that number, unfortunately, for mites and for many of the other situations. And if we wanted to try to do something, it's going to cost us time and cost us money. So we talk about the red line of hopefully our pests not passing the red line being economic injury level. So as their numbers grow, the pest is doing very well for itself at the expense of our crop plant or our host in case of honeybees. And it may then pass this line. If we apply a control, can we knock that number of mites back down below that level? The pest is going to grow again, and then it's going to grow again. And so it's never a stable line. And our issue with bees is we don't have a good measure of what this threshold is, what number is, how many numbers in a bee colony are going to cause some harm to the bee colony, to our harvest of a lot of honey, to whatever, our enjoyment of bees, whatever our objective is in keeping bees. We don't really have that. And of course, that is going to vary for someone whose livelihood is bees and the income from bees. That's going to differ from you and I, where perhaps we can stand a heavier level of loss, a heavy level of stressors, and still have survival of our colony. It may not do as well in terms of pollinating next spring or producing honey this year, but for some of us, that's not the critical factor where the larger scale beekeepers, that's their income to be able to produce. Now, I have an asterisk by knowing the enemy because in fact, what we're talking about in the system is we're talking about varroa mites, but the varroa mite is an enemy simply because of the pathogen, next please, that in its feeding on the pupae and it's feeding on adults as it's passing information and food to the queen, it has the possibility of enhancing the development of some viruses, particularly the two groups of viruses, the deformed wing virus group and the parasitic viruses, of which there are several. So it really is not the vector, the mite itself. What we need to know is what is the level of virus? And that's our shortcoming. We do not know. So we're going to try to say an economic injury level of the virus, the pathogen that's actually going to cause the damage, we don't know. So we have to seg back to trying to fix that with varroa. And so our new 9th edition has even ratcheted down further what we think would be a risk level. And so we're saying for this time of year, 2% or lower level of mites in a colony. Well, in fact, it is really not the number of adult mites. That 2% is 2% per 100 bees. It's not the number of adult mites that is critical. It's the mites that are passing the viruses that is critical. And again, we don't have a way of getting at that particular number. So next, in an IPPM, an integrated pest management. By the way, I've talked about a bunch of these with the Beekeeping Today. I do a 20-minute Beekeeping Today podcast every month. So if you're interested, I've talked about this and lately the supering and taking supers off for our management. I try to make a timely topic. Next. So the difference are that the bees have lots of viruses. Some of them, such as some that might be more familiar with, for example, a sac brood virus. Sac brood virus, we see it being manifest in the sac-like larvae of the bees. Adults have it, but it's asymptomatic. You just can't see those adults that have it. Or black queen cell virus, that is something that affects workers, but when it affects queens, the name signifies it becomes very black. Then you're not going to have a brand new queen that's going to be enjoying the herd, enjoying the colony. These are not varroa transmitted. The ones that I've talked about, the DWV and the paralysis viruses, are the ones that are of most concern. Next. So it turns out that in our best management practice, we have to do some managements that we really are not knowing the level, actual level of the pest. So in the wintertime, we recommend that we do reduction in terms of the chance of reducing the number of overwintering female mites. Okay, we do this without sampling. That was one of the 4 things that I mentioned was the case. And we're only trying to, the only mite phase that we're after would be the phoretic or what we call dispersal mites. So oxalic acid is our tool, using vaporization or using the dribble method. We're never sure when exactly we might have very little brood, so we'll often bracket this once a month, once in January, once in December, January, and February, or once or twice or 3 times during the winter. So this is still our IPM practice, even though we're not doing this level of sampling. Next. What our target is with the oxalic acid is this. That little bit of a sliver of what is the mite's body in the winter on its dispersal phase on the adult bees. Oxalic acid is a contact material. So when we vaporize or we use the dribble method, we've got to get enough of that oxalic acid on that little slip. Okay, so it's a pretty tough sell. And that's why it's not, a real effective treatment, but it's one that we still practice, because if we can get rid of some of them, at least we'll have fewer numbers. So back to the seasonal management, that I indicated, next. The time that we need to do our continuation of IPM is not to wait till August, September, that interface back here, where most of our tools are. It turns out our tools can also be very effective back here in spring. So this is where we've got to do our control. Next. Because in spring, what we're after is the foundress mites, the female mites that have survived the overwintering period, that then enter the brood cell. If they enter a drone brood cell, you can see the large, this is the pink eye stage of the drone. Here's that foundress mite. When they enter that cell, they're able to normally produce on average 3 adult females, three females that are able to then continue their population. If it's in a worker, it is a single one, okay? So what can we do in terms of our management? Not waiting at this time of year, but should have already done already. We can use the materials that are available, even though they're developed for later in the season, such as our synthetic apicide, Apivar, still effective. We're looking at commercial beekeepers. It's no longer the 99% effective, but it's still in many cases above 90%. As we look at commercial operations, there are some colonies where it is only 50% effective. So in effect, overall as a tool, at least commercial beekeepers are losing it. Not because they're using the chemical, the Apivar strips, but because they are making their own secret sauce that is not done correctly in all cases. Or using the essential oils, the Apigard, Apilite bar, or next, or formic acid, another of our tools. All of these tools can be used again in spring, because the vaporization or the dribble is not going to get all those mites that are hidden in those segments of the bee over the winter period. Now we have a chance to try to get the mites, for example, that are dispersal, but dispersal over a period of time. So the Apivar 2.0 is in the colony for 3 weeks. So we're every day trying to kill that dispersal phase of our mites. Likewise with the fumigant of the essential oil. The acid, if we use the 2 pads, we're also getting penetration through that porous capping as well. So we're getting a dual action, not only dispersal, but also the reproductive phase. Our knowing the enemy, we know that in addition to the dispersal phase, there is the reproductive phase. So that's that mite that goes into the cell during the capping phase, and then that's where she's reproducing herself. We have no way of measuring that number, and that is what is critical up through now this period of time. We can measure the dispersal numbers now after the summer solstice, but up until this time, we have no measure of getting at how many are reproducing mites. And we know that the vast majority are reproducing mites during that spring period of time. Now there's going to be more of a balance between those mites that are reproducing in the closed cell and those mites that are dispersing. So that now our tools can be a little more effective. That's why we developed the tools for that particular phase, okay? And of course, we started with pesticides kill bees. Now this is Bill. You recognize I don't know if you recognize the shot, Bill, from one of our apiary days, our pub apiary days. We put in a green frame that was the foundation for drone size cells. The queen came along, laid unfertilized egg, and now we have a frame full of drone brood at the cap stage. So they're still capped, the cells are still capped. We've taken a capping scratcher and removed the cappings here to show what's going on. So what we can now do is manage that tendency of mites to go into the cells of drones, because it's hardwired in their biology to know they're going to be more successful at reproduction if they pick a drone cell versus pick a worker cell. Next, rather than this arrangement, some of us will use a medium-sized frame and a full-size box. The bees don't like that empty space below that. They'll build comb in the spring, all right? And then normally that, most of that comb, good portion of it will be drone. In this case, all drone. Sometimes there'll be some workers there in the middle of it. So that in both of these cases, we know where the bees are raising their drones, okay? We're causing them to raise them in places that we know when we go back into the county, we can find a majority of the drone brood. And we can know then do our proper timing, okay? Again, timing is critical. If you do not capture these drones at this point, you in fact have a factory of mites. You're trying to grow more, you're not trying, you are actually growing more mites. So you actually have to harvest them at this stage. Next, if you don't have that, then make a sampling of wherever you find the drone size cells. In this case, we have the capping scratcher. We've impaled right through the cappings of the drone size cell. Turn the capping scratcher over and we can see we have a mite here, we have a mite here. So in roughly this 2 dozen cells, we have captured 2 mites in their reproduction. Now you can destroy these mites or these mites drop off and drop back into the colony. But even a mite only have about on average 4 reproductive periods in her lifespan. She'll lay 5 or 7 eggs at every one of those times. So we've destroyed one of those 4 periods of reproduction. So we've actually cut, in this case, for at least 2 mites, the reproduction of about 25%, a quarter of their whole ability to reproduce. That is significant, okay? Now, we do know that you may look in here and not find a single mite, okay? Or here, might not find a single mite. And so in our sampling of where the bees themselves are putting drone brood, or we have them do that, is what we need to do is do sampling from several different places. They somehow have certain families of drones that they prefer. And so here you see 2. I can uncap another 20 from somewhere else and not find any, or another place, not find any. So for some reason, this drone brood is more attractive. So this is both a control as well as now an estimate of sampling. It's hard to give you a number. The work that was forecast to do this, giving us this number, was not done. And the original money to be looking at this issue of mites preferring drone brood to this magnitude in our bee colonies. So when you do this, what I recommend is you do something in the vicinity of 100 drones. And if you are indeed finding that you have a couple or more that are reproducing, you're seeing the mites, then what it means is that you need to up the game in terms of going ahead and changing how you're thinking of mite control. This by itself is a mite control. So you are affecting both with sampling and with control by doing this capping scratcher. Bill.
Bruce, that's.
Bruce, I'm sorry, Bruce. I said
Anyhow,
Howard.
when do you suggest putting the drone frame in the hive?
I suggest in spring, as soon as the colony is developing, and so that's going to vary. Timing is in part a factor. Put it on the edge of the brood area. As soon as you start getting 2, 3, 4 frames of brood, it's time to put in for example, if you want to use that green frame or the medium frame on the edge. All right. At any time you see drone brood in the colony, you can go ahead and do the capping start. Because that's the bees managing you. They're on their schedule where they're going to put drones in.
As you get closer to fall, should you take the drone brood out? I know what's going to happen. I put it in there and the little rascal's still full of honey.
So, so a lot of things don't occur. One of the things is they don't build the drone cells. The second is that they don't raise drones. So if you are finding colonies that still are raising any number of drones, it's an issue that there is some stress that's going on in the colony. They should be about now with the summer solstice, they should be cutting back in terms of raising drones. There will be adult drones present, but not the rearing of drones any longer.
So now is the time to take it out?
So now's the time to take it out. It's not effective as a management now. Timing is everything. this case it's spring. Next, okay, so, we haven't, developed a technique to be able to actually sample the drones, in terms of finding out the number. So this is a sampling for reproduction by mites. Looking on drones, and looking on worker bees is a measure of the numbers of drones, right? So that's a drone that obviously, raised a whole family because you can see multiple mites on that drone. Next. Now we have a couple another, in our new, ninth edition, we're talking about the use of extended, materials for oxalic acid. So I said it is a contact material and it is not effective, has no residue at all. So after 2 days after you've used this material, it's no longer being a tool, no longer a killing machine. So what we have developed, of course, is an extended use of oxalic acid in the product Viroxan, or to be able to have an easier way to dribble at this time of the year with this ready-to-use oxalic acid. And the issue is now, just as with our extended or our use of, for example, the Apivar, the Amitraz, that's in the colony for a 3-week period of time. Now we have this oxalic that is only useful for a very limited time, but it's present for a much longer period of time. So now we're going to leave this in the colony for as much as a month. Months to 6 weeks. If they dry out, you can go ahead and replace them. Some of us have been doing this with the technique that Randy Oliver has discussed of using the Swedish sponges and putting them in a glycerin material and absorbing the oxalic acid into them. This is the product that does the same thing. And roughly it's a cardboard strip and you tent them over the frame. So we recommend with this product that once you have low numbers, because you've done some control over the winter period, or you've used one of these chemicals before you start thinking about adding supers as the colonies are expanding in the spring, then to go ahead and use the extended oxalic. No harmful effects shown with oxalic. It's part of some honeys. It's so far nothing has shown up in terms of resistance by the mites to oxalic acid. We do know oxidation with this acid does promote some bacteria, that the bacteria are in the mite system, so that our continued use of it may in fact promote certain bacteria that are going to be yet another issue, and eventually we may lose the use of it. But for the present time, we don't have that as an issue. Yes.
Oxalic acid sponges in the fall.
So the oxalic acid sponges like now, if we still have supers on, yes, absolutely. What we want to try to switch a little bit is as we take the supers off, is get back to the pest management aspect of how many numbers are there. So actually doing some sampling, doing the sampling of the adult bees now, and then on that determining, do I have my mite numbers under control, or is there 1 or 2 of my colonies where it's not as being controlled as well? So now you then have risk assessments of individual colonies. You know, we can do that on all 10 or all 20 of our colonies, where commercially they'll make that risk assessment on a whole apiary sample. And then the double-stranded RNA material, Naroa. This is no longer going to be effective through the rest of the year, but what is an effective material in the spring, because to be able to have this be effective, Naroa is a new product, and what it does is the reproducing mite, if she is exposed to enough of this material, her eggs will not meld into the nymphal mite stage, because a certain set of proteins will not fall into place. So her eggs become blob-like, never become the developing mite that will occur in the cells without that. next, if we can see that, okay. The illustration here I want to show, and this is from, so some of our information in terms of how important managing drones in our county and knowing about the drones on our, the mites on our drones comes from a fellow by Zach Lamas, who was a University of Maryland student working partly with USDA. And so what he's saying is our new treatment paradigm is treatments will shift from knockdowns to months-long protection. Now, all we have is the possibility of knocking the numbers down. And we really don't have very many products. Really, only formic acid will be a very good knockdown product. But if we've been using this material throughout the summer, applied in spring through summer during a honey flow, then what we're having is low mite numbers, and our county's winter fall with bees not impacted by varroa. In his newest work, Dr. Lamas is showing that it is not necessarily the number. I mentioned it's not necessarily the varroa, it's all about the viruses. But it's also not necessarily about varroa per bee, but how many bites varroa have taken on bees. And so it is all about those varroa bites. And with the issue of the dispersal phase of the mites of the varroa switching from host to host to host to host, once they're in a cap cell, they're confined, they're in a prison for the period of that. But all that switching, the fact that queens are susceptible to the mites as well. And if the mites are fed and taking care of their queen, the retinue bees of the mites, they can then enhance the varroa in the queen itself, and then in her eggs, then the queen is enhancing the development of varroa. So there's transmission between colonies and within colonies, vertically and horizontally within colonies. And what it amounts to is the number of times varroa that have the virus, the number of bees they impact in their lifespan. So that we might find as number of bees in our assessment, a number of mites for 300 bees, we might find only, let's say, 3%, nine mites in a 300 adult bee sample. But in fact, that is those 9 mites that we've washed off the adult bee bodies will have had a chance to touch many other bees that are in their colony and then affect the queen, who then is affecting the whole reproduction through of the bees themselves. So it's mite touches. Yes, nice data to back up this particular aspect as well. So the Varroa, in terms of its effectiveness, is mites go in and then they attempt to reproduce in that cap cell. Here's the family that she is growing. All right. And if she has been affected by the virus, she's affecting this bee, of course, as it is growing, but also then reproducing some of her own kind. Now, if that developing pupa has been exposed to enough of the double-stranded RNA, then that mite that goes in is she's been a non-reproductive mite. She still can transmit the virus to this individual bee, but she's not then growing a whole family of mites, the female mites, that can then do the same thing. Because through a novel series of experiments, he has actually infected mites that go into the cell and show that mite feeding on the pupa then affects her offspring. So if she has the virus, she's also affecting her offspring. Again, not necessarily that how many cells are infected, but how many mite bites are occurring in this whole system. Okay. And finally, yes.
Dewey, for Varroa, I thought you could also use it in the fall, like if you did a knockdown, so you had low numbers, because then they store it and they would eat it all winter. Is that the idea?
Well, so the question is, could we then use it in the fall? The data is not at all very clear that it is an effective treatment in the fall. at the price that we're paying for this treatment, we've got to try to maximize
Yeah.
its use. So the issue is, if it is stored, the mite, has to have enough of the material. And she'll get that from nurse age bees feeding the larva going to the pupal stage. And so when she feeds on the pupal stage, she gets enough of the material. The bees just are not rearing enough brood in the fall, to make this effective. And this fact of storage, so when they're storing food now in the fall, is that food that the nurse age bees are gonna get to in the spring, or is it gonna be any bee that's in the population? In the spring, there are not very many nurse age bees. It's mostly older forager bees. And so they're the ones that are going to be eating that particular stored food. So we're not getting it to that nurse age bees as efficiently as effectively as we need to.
Got it. Makes
So
sense.
it's really not cost effective. So it's really spring, and we can feed it too early in the spring, or we can feed it a little too late in spring. It's really, timing is gonna be very, very critical, I think, to be effective. Of course, we know that bee stock is going to be our eventual solution. Yes, we are working on different stocks. What you need to try to be thinking about is who are the suppliers that are using some of this technology? Who are the suppliers that have the stock? Is what a California bee breeder know about my bees in an Oregon backyard, is that sufficient to go ahead and give my business to that person? Or someone in a more local area, or myself rearing my own queens, is that effective? We should be thinking now of rearing the queens that will be our spring queens, okay? If we're not as successful as early in the year, but we're busy with other things, so we need to be thinking of our stock at this time of year. Even though it's harder, in fact, much harder to rear queens at this time of year. We're right on that cusp of where the end of June, the people that are doing this local stock selection now can make us an assessment of what might be the best stock, and also still have a great deal of success in rearing new queens. The later we drag that into the fall, the less again, timing, less effective it's going to be. So in terms of rearing queens, our bees have been doing rearing of queens during the spring, okay? During colony buildup, when the conditions are strong enough. We in industry rear by dequeening, making an emergency queen rearing condition. The bees right now, this time of year, are doing their requeening by the process of supersedure. The least understood of all of these are in fact supersedure. But of these three methods in terms of queen rearing, okay, we no longer going to be effective in trying to have our stock raised through swarming. We can still do this emergency queen rearing, or leave the issue to the bees to do that by supersedure. The process we understand a little bit less. So often our technique, of course, is this emergency queen rearing. And we can do that by now, the colony still being strong, of setting up resource nukes and trying to get resource nukes up as strong enough to try to get through the winter period, rather than using the resource nuke as a nuke immediately. Do a resource nuke as an overwintering colony, overwinter those colonies, and then we have the resource to be able to take care of emergency situations with queen rearing in the spring. To take and even though our losses were 21%, that's still, losing 1 in 5 colonies, using the resource nuke as the replacement next year. So we have our sort of our ideal number of production colonies. And then also being able to use the resource as for weaker colonies would brood, whatever, because now we can replenish our resource nukes at this time of year by making them up to try to get them through winter. And the secret for a 5-frame resource nuke is that you have roughly the equivalent of 5 frames of honey. Okay, you can achieve that through feeding or by stealing from other colonies. We don't need to overwinter those big, strong, populous counties. We can more easily overwinter the smaller counties and then have that versatility next spring to grow them into production counties or use them to take care of issues that happen in the spring. So we have that number of production counties that we're looking for. I think that's all that that's the last one. Yes, you got Varroa. Right, if you've been monitoring Varroa, you'll notice that by looking at adult worker bees, numbers have been zeros and ones and twos, and all of a sudden now we're going to start getting numbers. And the reason for that, there are several, but one of the major reasons for that is now there is no longer that reproduction occurring in the drones. And so successful reproduction occurs in the worker cells. So now when we look at the worker bees, we pick on the nurse age bees, we're going to now start picking up numbers of dispersal mites on those worker bees. It's not that they didn't have dispersal mites earlier in the year, but most of those mites were on the drones, we weren't looking. Now when we start looking at worker bees, we find those numbers. I do certainly recommend that you start this month by doing the washes of adult bees. Your numbers will likely be low, but as soon as the supers come off, you'll find that the numbers increase very dramatically. That can then pinpoint where you want to spend your resource dollars, your resource time in terms of trying to reduce the size of mite populations. Questions and comments?
Questions from online, just type them into the
Okay.
chat and I will get them.
Who's here?
First year beekeeper says, this was fantastic. Thank you so much.
It's a lot to digest. It's a lot to
Yeah,
digest.
and this is recorded, so you can play this back.
So what I was asking about earlier is spider venom peptides.
Spider venom peptides as a
And arthropods in general, it appears as though it would be it's HT1A and GT1A peptides, currently available in a lot of different arthropods. The study found 78% of the 50 peptides we tried killed Varroa in 24 hours. Do you know anything about that at all? There's 2 papers I read on.
Okay.
But that's what I'm looking at.
So there are a bunch of biological mechanisms, plants have mechanisms. There are some plant materials that are, nettles is one of them, but I'm thinking of tobacco, of course, that are active on their array of pests. Our issue always is trying to find the amount. So you gotta do a resource, a curve that says, this is too little, this is too much, but this is the amount that will kill the pest, not harm the host, of course, not get into honey, not gonna be absorbed into the wax. So it's just, the bug on the bug, the Varroa on the bee is just that extra complexity because we're gonna use all those things from that host in addition to its population, as part of how we're going to measure our success with it. But there are a number of these other types of compounds that may well have possibilities. There is an EPA procedure where some of these do not have to go through the extensive testing as if you are developing a synthetic pesticide. There's a fast track for some of that. It's still expensive to try to get some of these materials that are available. There certainly is the possibility of some other things that are out there. The spider, not really before, but that's a possibility.
Question from online.
Yeah.
Any issues using oxalic or formic acid during the Varroa treatment period, 10 weeks?
When you're feeding Varroa, we don't want to have other feed on the colony. If you are treating at the same time that you're using Varroa, I'd have to go back to the label and take a look at what it says. Does anyone know Charlie? Charlie is a distributor for Varroa.
The question is, can you use
Formic Pro or oxalic acid at the same time as Nora.
Correct.
I think if you go out to the Nora website, they actually suggest you put both on at the same time. But
Oh.
what Dewey is trying to say is do not have any honey supers on. You're trying to get them to uptake that Nora, the sugar syrup, and store it on the brood frames.
Yeah.
That's the real key.
Yeah, Naroa says to reduce the numbers to a lowest level as you can, so do your treatment and then put the Naroa on, yes. But in this case, doing them simultaneously would probably achieve the same thing, because Naroa has to work over the lifetime of mites doing their reproduction. So the Naroa, the double-stranded RNA, is not a fast, quick action treatment. Yeah, thank you, John.
What do you think about that super clean yeast stuff?
Canadian rocket fuel, they are.
It's rocket fuel. How could it
rocket
be
fuel,
different?
right, it's,
Come on.
it's a method of, in a much shorter season of building colonies very rapidly. So it does seem to indeed, be able to enable to do that. It's also an environment where they might not get very much forage time in any one day. So this is apparently they have added enough attractions to the sugar syrup that they're now taking it down in much larger quantities. And in addition to getting just the carbohydrate, we're also getting some of the protein. The larger scale Canadian beekeepers, that's where the name comes from, are quite ecstatic about it. And now it's going to be very readily available through Man Lake since they bought it.
One more question online. First year beekeeper, new swarm colony. Have not tested for mites yet, but recently have seen deformed wings. Is the powder sugar method still okay, and oxalic acid for first time treatment?
So if we see deformed wing or mites on adult bees, it's not a good sign, because there are so few that we can even possibly encounter that way. So that's not a good sign. The powdered sugar is not an effective means at all in terms of treatment. Not numerous studies have shown that. It's not much difference in a screen bottom board, very passive level in terms of control. So the powdered sugar, we use the powdered sugar to do our assessment of mites on adult bees, but not as a treatment as such.
One more question. It's kind of a long one. Tried Formic Pro 2 weeks ago with a Hive IQ. Hope that the built-in entryway would provide adequate ventilation. The entire colony immediately left, bearding on the hive and swarming on the surrounding trees. A large number of deaths inside. Surviving bees never got the benefit of the dispersed gas inside the hive. I removed the Formic Pro pads after a week, collected the rogue bees and put them back in the hive. Has anyone had success with Hive IQ or other measures?
So Hive IQ is a much better insulated colony. The formic is actually not a fumigant. The formic is like also contact material. We know bees will abscond, will leave their home for a number of reasons, and chemical treatment is one of them. High mite numbers is another one. Ants as a pest is another one. So there are several of these reasons. So that's what happened with a couple of these different chemical treatments. And formic is famous for this, but also in the thyme oil, you'll get bees coming out and bearding, but then they go back in. And I think perhaps the combination with the Hive IQ. Anyone else have Hive IQ?
I haven't had a problem.
With formic, have you used formic?
I've used formic without problem.
Yeah.
They beard no matter what you do,
Yeah,
but.
they will beard, yes, they
yeah,
will
I
beard.
mean,
I think a factor of the time and in terms of the treatment. I would not be thinking of formic unless I knew I had very high mite numbers. Because formic has all these other collateral damages. Yeah.
Okay.
Really hot 2 weeks ago. With temperature restrictions on formic.
Yeah. And there is temperature restrictions on both the time oil, the essential oils and then yeah, roughly, although it does give a higher temperature, we gotta really think 65, 85. But leaving it high and bearding is common with not so much absconding, but that's certainly very. Bruce,
And what's the temperature range for salmon?
again, 65, 85, but I think probably it says up to 105, but thinking 65, 85.
Now, 85, what happens, you're looking at, we got a period where you're below that 85, as you're looking way down on the weather forecast, it's gonna go up. What's the period where it has to be at 85?
So.
Got to taper off a little bit, where you have to worry so much.
So what we say with both formic and the essential oils, roughly that first 3 days, because that's when you get that very, very heavy off gassing of the material. So the first 3 days. That was on mine? No.
Okay, guys.
Okay. Thank you. Appreciate it.
We have a raffle, we're raffling off honey tonight.
So we have 12 jars and we have 13 tickets.
Why don't you just grab a jar on the way out?
I have paperwork that was loaned to me.
This is honey
By
from the
Brian,
American
I believe.
Black.
I picked it up and thought, I wanted to return it, I kept it longer than I should.
Oh, okay,
It works fine.
that's great.
It's part of the library, so.
Oh, thanks. Yeah, that's perfect.
So I got
Right.
the batteries, different way to do it. Wanted to buy
You think
one.
that's that? You think?
Okay,
Yeah.
all right.
Oh,
3 t-shirts.
Talk
I think I
to,
can close this out, right?
guy standing right there at the end. And grab a jar of honey on the way out.
Stop.
Thanks for returning.
Share.
Sure.
All right, goodbye, folks. Thanks for joining.
Excuse me.